Well, hello everyone, and greetings from not so sunny Syracuse. I hope this thunderstorm behind me doesn't interrupt too much, but like Mark said, my name is Rich Dausman, and I'm the president here at Cryomech, where we design, develop, and manufacture Gifford McMahon style cryocoolers, as well as cryogenic systems, such as liquid helium plants, liquid nitrogen plants, and specialized cryostats. We're a growing company with close to 150 team members, and we currently produce about 20 systems per week, which puts us in the 1,000 systems per year range. In addition to our manufacturing side of the business, we also have our very active, innovative, and important R&D group. And we like to refer to this group with a lowercase r and an uppercase T to emphasize that while we do spend some time on research, we do spend most of our all starts with Bill Gifford, inventor of the Gifford McMahon refrigeration cycle and founder of Cryomech in 1963. Fast forward 58 years, and here we are in front of our brand new state-of-the-art custom-built facility of 72,000 square feet. We're 100% employee-owned and committed to carrying on Bill's legacy of continual innovation, listening to and partnering with our customers, and equally as important, preparing for our future. Cryomech manufactures the most extensive, most powerful line of cryocoolers available in the world. Our latest example is the recent release of the PT425 pulse tube cryocooler, which provides 2.7 watts at 4.2 K. This is an impressive increase in performance, which was our previous most powerful system, our 2-watt PT420. And equally as impressive is the fact that this PT425 is the same physical size and draws the same amount of input power as our 2-watt cryocooler. The remote motor version of the PT425, pictured on the right, delivers 2.35 watts of cooling power at 4.2 K. Our remote motor PTs are an enabling technology for dilution refrigerators, which is our current arm's length connection to the quantum ecosystem. We supply custom designed cryocoolers to each of the world's dilution refrigerator manufacturers. In turn, dilution refrigerators are enabling technology for quantum computer manufacturers like the IBM and Googles of the world that employ superconducting qubits. Larger, more powerful quantum computers are forecasted in the timelines and technology roadmaps of all the quantum computer manufacturers. The scaling from present-day 50 qubit systems to 1,000 qubit systems within the next 3 to 5 years will require more powerful cryogenic platforms. To keep pace with this advancing technology, we have been focused on designing and developing larger cryocoolers. Jumping to the opposite side of that spectrum, the QED-C put out a call for advanced cryogenic solutions to accelerate research and commercialization of quantum information science and technology. To answer this call, Cryomech is focusing in on what's been termed low C-swap cryocooler technology. That's low cost, size, weight, and power. This technology will enable deployment of small cryogenic quantum sensors and cryogenic quantum network repeater nodes. These quantum network repeater nodes would benefit from highly efficient superconducting nanowire single photon detectors. We are developing a sub-3 K pulse tube that will cool an SNSPD manufactured by fellow QED-C member Quantum Opus. This development is partially funded through the QED-C and will provide what we believe to be a first step towards C-swap cryocooler technology. And finally, like everyone else these days, it seems we're looking for help. In the true Bill Gifford Cryomech spirit of continuous innovation, listening to and partnering with the scientific community, we're looking for assistance from technical collaborators, QIST product developers, and any others in the quantum quantum community to advance the necessary low C swap cryocooler technology and provide input to aid in the design of our next generation products. We look forward to connecting with you and innovating the technology of tomorrow.
So Cryomech is a key supplier to dilution refrigerator manufacturers. So you're an OEM supplier, right?
Yes. Yes.
And you're shipping pretty high volume per year. So this more powerful pulse tube cryocooler under development. Can you share a bit more about that?
Maybe a small bit about that. As I said, our largest cryocooler right now is 2.7 watts at 4.2, and currently, we're hoping for another 50% increase, quite possibly, in the cooling power. We've not turned it on yet. We're working towards that, so we'll know more probably in the next 2 to 3 months.
Great, and that's pretty important, right? Because in the marketplace, as one person I talked to in the cryo space says, the quantum computing companies that need dilution refrigerators keep needing to build bigger dilution refrigerators.
Right. And many of the dilution refrigerators being built now have multiple cryocoolers in them. So you're talking footprint space for the compressor systems that go with those cryocoolers, larger footprint dilution refrigerators to house those multiple cryocoolers. So the more powerful cryocoolers then would reduce the number needed because they provide that cooling power in a single unit as opposed to multiples.
Oh, I see. So now you get more space.
More space and hopefully less input power as well.
I see. Great. And then can you go to slide 7?
Sure.
Actually, here's a question from Raymond Bunker. Can you comment on any developments with respect to vibration mitigation for dilution refrigerators?
I can only speak to what we do here, and that's the reason why the dilution refrigeration folks use our remote motor. What that does is it separates the electrical motor from the actual cold finger, which reduces vibrations, so that it's less work for the dilution refrigeration manufacturers to dampen out any vibrations coming in from our pulse tube. So they each all do their own work as far as dampening vibration and how they connect our pulse tube to their dilution refrigerators, with whether it's braid, straps, thermal straps, those types of things. But that's really the dilution refrigeration manufacturer's technology and probably trade secrets.
I got it. Thank you. And single photon detection is another hot area. Can you share a bit more about the cryo technology you're working on there?
A little bit. That's something new, certainly less than 3K. As what was called for here, right? We have a base temperature of less than 3K and a heat lift of about 100 milliwatts at 4 Kelvin. So we're sort of aiming in that area. And the whole difficult, I guess, there is, that's a different realm. We've not gone there before for us personally here with our technology. And so it's not only the pulse tube itself, but it's also the compressor technology to draw that less than a kilowatt input power, long maintenance cycles. So that's the challenge, and that's why I'm saying we're reaching out to the quantum computer community to network and to collaborate with, because this technology isn't there, and it's going to take a number of us, I think, putting our heads together and really advancing the technology.
Great. Thanks, Rich. And hopefully we can do some more Q&A at the end. Very, very impressive.
Thank you.